Hello everyone. Today we are going to discuss about chi-square distribution as test of goodness of fit. Introduction to chi-square distribution as a test of goodness of fit. The chi-square distribution is a probability distribution that is used in statistical tests for goodness of fit. It is often used to compare observed data with expected data to determine if there is a significant difference between them. The chi-square test of goodness of fit is used to test the hypothesis that the observed data follows a specific theoretical distribution. Assumptions of chi-square test. The observations must be independent. The data must be categorical or discrete. The expected frequencies for each category must be greater than 5 to ensure the validity of the test. Steps in conducting the chi-square test of goodness of fit. State the null hypothesis and alternative hypothesis. Choose the level of significance. Collect the observed data. Calculations of the expected frequencies. The expected frequencies are calculated based on the assumed theoretical distribution. The expected frequencies for each category is the total number of observations multiplied by the probability of that category in the theoretical distribution. Calculations of chi-square test statistic. The chi-square test statistics is calculated by summing the square differences between the observed and expected frequencies divided by the expected frequencies. The formula of chi-square statistic is x square is equals to summation of O minus E to the whole power 2 divided by E, where O is the observed frequency and E is the expected frequency. Degrees of freedom. The degrees of freedom for the chi-square test of goodness of fit is calculated as the number of categories minus 1. It represents the number of values that are free to vary in the calculation of the test statistic. Critical value and decision. The critical value for the chi-square test is determined based on the level of significance and the degrees of freedom. If the calculated chi-square value is greater than the critical value, we reject the null hypothesis and conclude that there is a significant difference between the observed and expected frequencies. If the calculated chi-square value is less than or equal to the critical value, we fail to reject the null hypothesis and conclude that there is no significant difference. Interpretation of results. If we reject the null hypothesis, it indicates that the observed data significantly deviates from the expected distribution. If we fail to reject the null hypothesis, it indicates that there is no significant difference between the observed and expected distribution. Advantages of chi-square test. The chi-square test is easy to understand and apply. It can be used with both small and large sample sizes. It can be used for both simple and complex categorical data. Limitations of the chi-square test. The chi-square test assumes that the observed and expected frequencies are independent and identically distributed. It is sensitive to small expected frequencies, leading to inaccurate results. It cannot be for continuous data. Example, testing the fit of a dice. Null hypothesis. The dice is a fair and follows a uniform distribution. Alternative hypothesis. The dice is biased and does not follow a uniform distribution. Collect the observed data by rolling the dice a large number of times. Example, testing the fit of genetic cross. Null hypothesis. The observed genetic ratios for the expected Mendelian ratios. Alternative hypothesis. The observed genetic ratios do not follow the expected Mendelian ratios. Collect the observed data by conducting a genetic cross. Example, testing the fit of a survey response. Null hypothesis. The observed distribution of responses follows the expected distribution. Alternative hypothesis. The observed distributions of responses does not allow the expected distribution. Collect the observed data from a survey. Conclusion. The chi-square distribution is a valuable tool in testing the goodness of fit. It allows us to compare observed data with expected data to determine if there is a significant difference. By following the steps and assumptions, we can make informed decisions based on the chi-square test results. Thank you.